8.1. A parallel plate capacitor with circular plates of radius 1 meter has a capacitance of 1 nanofarad. At t equal to 0, it is connected for charging in series with a resistor R equal to 1 mega ohm across 2 volt battery. Calculate the magnetic field at a point B. Where is point B? Here. You have to find out magnetic field. Halfway between the center and periphery of the plates. In between of this. After t equal to 10 to the power minus 3 seconds, the charge on the capacitor at time t is q of t equal to Cv into 1 minus e to the power minus t by 2, where time constant 2 equal to Rc. Okay. First, what are the given values? We'll try. Radius of the plate is R is 1 meter. Point B is at the distance of 0.5 meter from the periphery. Capacitance value 1 nanofarad. Resistance R equal to 1 mega ohm. Mega means 10 to the power 6 ohm. Battery voltage is given. Time limit is given. And time constant formula is also given. RC equal to 10 to the power 6 nano. Right? Minus 3. Now, what's the formula for displacement current? Displacement current is epsilon 0 d phi E by dt. Okay, we'll start now. First point, electric field. Flux is equal to field into area. So, electric field equal to flux divided by area. What is electric flux according to Gauss theorem? 1 by epsilon naught times the charge. So, electric field becomes flux divided by area. Flux is Q by epsilon naught divided by area. Area equal to pi r square. Initially, radius is 1 meter. So, pi. So, what happened? Area becomes pi. So, electric field equal to Q divided by area is replaced by pi epsilon naught. Next, what is electric flux through the loop of radius 0.5? It is in between, right? Point B, 0.5. What is the flux through? Only the radius 0.5. Flux equal to field into area. Field equal to Q by pi epsilon naught. Area is pi r square. So, if you substitute, pi get cancelled. Q r square by epsilon naught. Q by epsilon naught. Radius is 0.5 meter. 0.5 matlab half meter. Half ka square 1 by 4. So, we got the formula for flux. Q by epsilon naught into 4. Okay. Next, displacement current is epsilon 0 d phi E by dt, epsilon 0 d phi E by dt. So, isko differentiate karo with respect to t. What happens? dq by dt into 1 by 4 by epsilon naught. That is 1 by 4 times epsilon naught dq by dt. 1 by 4 if you leave, dq by epsilon get cancelled dt, right? So, id becomes 1 by 4, q equal to it. Rate of change of charge equal to current. So, q equal to I into t. Next, finding dq by dt. Okay, we have to find dq by dt, right? So, this is the given expression. dq by dt means you have to differentiate this equation with respect to t. That is equal to d by dt of Cv into 1 minus e to the power minus t by 2. Here Cv is taken as constant. So, Cv taken out d by dt of 1 minus e to the power minus t by 2. Differential of e to the power minus t by 2 with respect to t is e to the power minus t by t into minus 1 by 2. Applying carefully dq by dt equal to Cv. Differential of 1 is 0. Differential of this term equal to minus 1 by 2 e to the power minus t by 2. I hope it is clear. First, I differentiated only this part. I got the result. I am substituting. So, Cv into minus plus 1 by 2 e to the power t by 2. That is what? d by dt of this one. That is nothing but dq, right? Yes, dq by dt we got this answer. Cv e to the power minus t by t divided by 2. This is e to the power. Okay. Now, let us start substituting. C value is given as 10 to the power minus 9. Voltage is 2. and time equal to 1 divided by 10 to the power minus 3. Time limit is 10 to the power minus 3. So all the values you have to substitute and then only simplification is left. So we are getting dq by dt is nothing but displacement current 1 by 4 it. Right? 1 by 4 it. How you got this step? From this only you are simplified. So id equal to 1 by 4. I is 2 into 10 to the power minus 6 into 1 by e. Now, you see a simplification. It becomes 1 by 2 10 to the power minus 6 into 1 by t. Okay. Now, we'll apply Ampere's second law. We apply Ampere's second law. Integral B dot dl is mu 0 into id dl. That is 2 pi r mu 0 id. What is id? id equal to displacement current. So B becomes id divided by 2 pi r substitute as 0.5, r value, then mu 0 divided by 2 pi into 0.5 d or mu 0 into pi, 2 pi, that is get cancelled, 2 and 0.5, so pi into id. Next. Okay, now we substitute mu 0 value, pi keep it as it is. id is displacement current. How much you got? Here value is there. This if we substitute and simplify, E value is what? 2.713. Reciprocal 1 by E becomes 0.368. So you are getting this answer. Magnetic field we got here as this much.